All right, we'll get started. Just want to thank everyone for taking the time to attend our webinar. My name is Blake Murphy. I'm the president of American Pipeline Solutions, and today we're just going to talk about a past project that we did with Mark Wade at BlueWater Solutions, utilizing both foam pigging as well as the I2I smart foam or smart pig. Just a quick kind of rundown of our company. We're a pipeline services company. We are nationwide, and we specialize in ice pigging as well as foam pigging, smart pigging or condition assessments, pipe mapping, and some internal pipe coating and rehab. So that's just kind of the quick primer on our company. And I'm going to kick it over now to the president of BlueWater Solutions, Mark Wade, so he can talk about this project.
Yeah. Thanks, Blake. Hey, I'm going to probably have you advance a slide. This slide sharing thing I think it's turned off again. So anyway, appreciate everybody joining this seminar today. My apologies on a couple of things. We babysat grandchildren last weekend, and so I've come down with a head cold. So if I'm pausing quite a bit to keep my mouth from drying out, that's what that's about. And secondly, I'm an engineer, not a professional presenter. So if I miss anything, if it looks like I need to drill down a little bit more on some details of the project, I think Blake's got this. You can submit questions. I don't know what the tab is, but you can submit questions. And we talked about toward the end of the presentation, we'll go through those. If anybody wants more information during the webinar, we can respond toward the end. Otherwise, we can get back with you. So we're just going to go ahead. Blake, should I just try to advance a slide, or you want to push it off to the first one?
Can you see the slides right now? I'll get your introduction slide.
I can see the first slide, smart foam tool.
Okay. Why don't you go ahead and start sharing your screen then?
Well, I thought, can you see me advance to the next slide that says about APS? Or which one are you on?
I'm on your introduction, Mark Wade.
Okay. All right. Well, I think I'm looking at a different presentation, a different version of it. So I'll just have you advance a slide and we'll go that way. All right. Well, real quick, my name's Mark Wade. I'm with BlueWater. We have been at this business of assessing, inspecting, evaluating, mostly trenchless type solutions, water, wastewater, stormwater for a lot of years. This is rolling up to year 46 for me. And that's just a map of locations where we've worked through the years. And I happen to sit in the Kansas City area, though I'm usually not there. I'm on a plane or on a job site. And there's the type of work. Our clients are all over the place. And depending on, funding that's available, a lot of these projects that we get involved with do advance to a design phase. And from design phase, of course, depending on the type of contract structure, if it's a traditional design bid build, or if it's a CMAR project, we tend to follow these projects all the way through. And like I said, that's the map of the U.S., but we've worked all over the world. Okay, next slide, Blake. This is so more about the project itself. It is a client of ours, city of DeSoto, Kansas, which is located just west of the Kansas City area. Since probably the early 40s, have had a large water utility to provide them with water as a big facility that manufactured and supplied equipment during World War II and also post-war years, about 5 to 6 miles south of town. That's where the water plant is, but the wells are up on the river itself, the Kansas River. There were at one time back in the late 40s and early 50s a total of 10 wells that supplied raw water, that pushed that water 5 miles south of town to the water treatment plant, which is where this other large industrial user was located, and then treated the water. And the water that the city was supplied with then was again provided as that water was pushed back to town. So it was quite a complex system at the time. And the city reached out to us in probably the early 1990s. This was before the pandemic. And we started looking at this pipeline because the concern was its condition. It had been in place, in service all those years. And around July of 22, as I'm showing on that bullet, we started to get inside the pipe. And that picture shows an example of one of these 16-inch ductile iron pipes. And we saw clearly that we are now down to operating about a 4 or 5 inch opening through a 16-inch pipe. A lot of material had built up into the pipe through the years that couldn't be pushed through, even operating this system at well over 100 psi. That stuff was not moving. And that's when we realized we needed a bigger tool from our toolbox to deal with it. So the pipes were jetted and cleaned. And until we finally reached a point where we decided we needed some smart technology inside this pipe. Now that the pipe was getting cleaned, what is the actual condition of the pipe, both outside and inside the pipe? Next slide, Blake. So the first the first major decision, and I think it was a good one, it was a group decision made by the folks from Ace Pipe and ourselves and the client, the city of Soto, was that if we're going to get in here and start launching pigs, starting with these soft foam pigs, and basically increase the pigging operation of pigs that would be firmer and firmer, with the ultimate launch of being a smart pig, we needed to kind of hit the pause button and move forward with the construction of what we describe as permanent pigging structures. And I think there were 3 or 4 of them that we had built, and it was on an accelerated schedule. So we accessed the water main. As you can see, we focused all of that effort in getting these structures in place with valving that would accommodate the launching of these pigs. And then these structures would then be used for routine preventive maintenance, i.e. launching firm pigs every 3 to 5 years. As we saw pressures increasing in the system, then the crew would go back out and redeploy the pigs and keep them cleaned. At the same time, that's when the news came that Panasonic and the city and the governor of Kansas got together and negotiated essentially a plan to build a new electric batteries for electric cars, which really accelerated then everything, because we had about a 2-year period to get this system fully operational and be able to push enough water from these, by then, 5 wells. 5 had been decommissioned through the years. HDR got involved heavily on getting these 5 decommissioned wells back up and running again, because we needed about 3 to 4 MGD of water. At the time, we were only getting about under an MGD. So there was a lot of spinning plates going on at the time. There were the well project. We had these 2 water supply lines that needed to be that needed to be fully cleaned, assessed, and rehabilitated. Plus, there was a lot of work going on at the water plant itself. So we were the group that was working in the middle between the wells and the plant. So the whole aim was to get the whole system up and online when Panasonic was up and operating their facilities. Next slide. So there was our project priorities were to, like I said, focus on these 16-inch water lines, the twin water lines, and also included in those water lines were to deal with the 12-inch mains that were connected between the 16-inch lines that were going to the plant and the existing 5 wells that were still operational. So lots of challenges, again, when you're working on a live water system, as you all know. So everything was done. We scheduled everything around nighttime operations. Got these access structures built, and then we were focused on trying one of these water lines that serves 5 wells on the north side of the Kansas River, actually push water underneath the river under an existing siphon structure there, and gets it on the south side of the river so it can rejoin with the wells on the south side. So we also were really focused on a successful cleaning and launching of pigs and smart pigs under the Kansas River. And as a result, also had to navigate through lots of valves and fittings of which we didn't know their condition because they were all buried. Finally, the last step of this was to figure out, knowing how much material we'd probably be pushing through these pipelines. The engineers at the water plant wanted to ensure that as we discharge this amount of material into their ponds, that they could be effectively managed. So there was other things going on at the plant because as these pigs exited the system, they were pushing a pretty large quantity of sludge. Next slide. So point here is anytime you get involved to any extent in these water systems, it's always good to have a very large toolkit, and we did in this case because we had two contractors helping us figure out what tools were the next to get inside these water lines. We had the Carillon Corporation and the local company, Ace Pipe, were the ones that supplied a lot of material to get the pigging operation completed, but the tool that remained that we didn't have access to, and that's where we reached out to APS, was the smart pig. It's probably one of the first. We've done smart pigging in the past, but this was one that we knew had to work for a long distance. And we, at the same time, I was working on the committee that was developing, the NASCO committee that was developing the expanded PACP codes for pressure pipe. And so those were also kind of that added library of codes for pressure pipeline was being developed by NASCO with this small group of folks. And we had to make sure as those new codes came online for pressure pipe, we already had software in place to manage that data. We had to make sure that the data that was coming off the smart pig, we could apply those new pressure pipe PACP codes, and also the new codes for valves and fittings, to be able to kind of integrate all that together. And again, while we're out there pigging and that kind of thing, getting this pipe clean and ready to launch the smart pig, we had to make sure we had a database that would capture this data from the smart pig, and we could post-process it and start to figure out what's going on structurally and hydraulically with the main. Next slide. So I'm just going to kind of jump forward to show you an example of what the I2I system actually delivered for us. And frankly, it was pretty remarkable. That there was really, everything worked as planned, on time and on budget, which is always a big deal. Nobody wants to go back to a client like a utility and try to get change orders on things because we found, unexpected issue. We literally didn't know what we're going to find inside this pipe until we got fully through it using the I2I tool. So as I said, it really did work flawlessly. It identified 4 areas where we started to hone in on wall loss on this ductile pipe. And one of the things it did for us, it measured the amount of wall loss deterioration in this pipe. And we bracketed that down to, I think, increments of percent and inches lost. So you can see there were 4 areas in particular, and that kind of shows in some of these graphs, where we were starting to see wall loss greater than 10%. And we just set that as a benchmark based on how the pipeline was operating under these pressures and surges currently, and how we expected it to operate when we were pushing water from all of the 10 wells as they were being put back online. The maximum value that actually we identified in the pipe reached about 15%. That is not the case on other projects we've worked on where we've seen wall loss much greater. But for this one, based on its performance, we were looking at those key areas where we might need to go back out and do some relining, rehabilitation, or some kind of trenchless solution where wall loss was a concern. And then we also had these other things called uncategorized signals that a couple of them we actually dug up to see what that really was. So the I2I is a wonderful tool to really kind of focus on structural integrity, hydraulic reliability, anything that may be occurring in there like an offset joint, pitting, things like that was really probably the strength of it. So that's the pigging result. Next slide. And the news got better. Those what the tool called uncategorized signals, they were detected. Of those uncategorized signals, they were what we identified as pipeline anomalies. There were 34 of them, and we were expecting it to be much larger because this is a 70-year-old pipeline that has operated continuously every day for 70 years and has never been inspected. It's never been cleaned. Nobody's ever been inside this pipeline unless it failed. And actually, it had even the maintenance records on the pipeline were limited. Of that, like I said, we only found 4 areas of concern, and one of them got dropped off. So we really had 3 points in this pipeline that we know we needed to go back out and reevaluate. And as I mentioned, that was simply to exhume that part of the pipe and see what were going on at these 3 particular areas. Thankfully, none of them were under the interstate or under the Kansas River. So we were happy about that result as well. Next slide. So the bottom line here, and there's a big, thick report on this project, since we had to produce the report to the city, and there was a lot of back and forth discussions about what next, and then the city shared the results of that, of course, with Panasonic as they were getting ready to put their facility online and needed a large amount of water. Was that there was no structural compromise found because we restored the hydraulic reliability of the pipe, i.e. going from 16 inches, going from a 5-inch diameter hole to back to that 16-inch diameter. We immediately got hydraulic responses from that. Operating pressures dropped significantly from, say, 150 PSI. We were finally operating the system down to 30 or 40. No immediate corrective action. And then we also put together a kind of a longer-term asset management program to make sure over the next 30 to 50 years, the city has the right resources in place to keep these twin pipelines humming for as long as they needed it. Next slide. Oh, and the future. See, is this? Yeah, this is my slide. I think this may be my last one. Future benefits. The data that came off the I2I, we felt was helpful in moving forward what we call a proactive PMP, preventive maintenance program. So the city has put things in place so that they will be able to routinely issue work orders periodically to keep the pipelines operating at their optimal level. And that includes this idea of routine pigging and inspection. So in this project, it was, I believe, Ace Pipe Carolina, i.e. Carolina Corporation, that left the pigs with Ace. The foam pigs were destroyed, so the city's just going to have to purchase additional foam pigs in the future. But to keep those tighter pigs in place, they kind of left the legacy equipment behind, they being Ace Pipe, so that the city could continue to pig the pipe routinely. And I think we've got the pipe cleaning scheduled for every 2 years. And the structures are there. So all it is simply a matter of shutting the system down, in the middle of the night, shoving a pig in, pushing it down to the plant, and then putting the system back in service. So they've done that once already, and we've got another cycle coming up where we're going to actually relaunch the I2I to see if anything else is showing up. Putting it into their program also means updating all of the codes that we collected that were related to the NASCO codes, because the city is using NASCO as a basis for their asset management of all of their buried linear assets. And supporting any kind of future modeling. I think one idea was, depending on how the demand changes, the I2I allows us to really predict what the hydraulic performance is going to be. If there's sections of the pipeline that we need to add additional capacity, we can do that. And just like I said, giving us increased confidence as the system ages long beyond our generation, make sure that this is a reliable pipeline for many years to come. And I think that might, let's see. Yeah, I guess I just talked through all of that. So Blake, if you can go to the intro, next to intro here and now, Bosco, and I'll jump off.
Sure. So now we're going to hear from Bosco Fernandes, who's one of the manufacturers and employees from I2I over in Manchester. Over to you, Bosco.
Thanks, Blake, and thank you, Mark, for your very comprehensive presentation. So just a brief word about what I2I Pipelines is. So we are a company based in Manchester in the United Kingdom. We manufacture tools for the internal inspection of pipelines. We manufacture mandrel pigs, which we call Pioneer tools, and we also manufacture smart foam pigs, which are what we are discussing in this webinar. Our sensors are based on eddy current technology, and they are embedded within the foam pigs, as you will see in the future slides. So primarily, the function of the sensors is to detect wall loss inside the pipe or patches of non-uniformity that result from pitting corrosion and such like. The tools themselves are very easy to deploy, and depending on the size, they can even be carried in a duffel bag and just popped into a pipe when needed. Our clients usually run them themselves. With a little bit of training, they are able to turn them on, launch them, recover them on the receiving end, connect to them, download data, and upload the data to our servers for processing. So they're pretty simple to use, and we've had some quite successful results working in the utility area. We are traditionally a company that has manufactured tools for the oil and gas industry, really, offshore and onshore, crude oil, processed oil, and gas. But we've also, in the oil and gas industry, we also run water lines as well, water injection lines, etc. Could you have the next slide, please, Mark? Blake. So what is a smart foam tool? A smart foam tool is simply a foam tool with a particular density of foam depending on the application. And it has on it, as you can see in the drawing here, it has blue stripes of polyurethane along its length. And within these blue stripes is contained sensors that are eddy current based sensors that touch the pipe wall. And as the tool is propelled through the line using the medium that is inside the line, in this case, water, it collects data from the internal surface of the pipe wall. So we measure the changes in the internal surface of the wall. Inside the center of this tool is an electronics unit, which has got the data acquisition system. A little bit of processing goes on in there, and of course enough batteries to last the duration of the run. On the back, on the left-hand side, you can see an odometer there that helps us determine where we are in the line. Inside the pressure vessel itself is an IMU, so we can detect pitch, roll, and yaw, and changes in direction. And we tie that up with the data that we get from the eddy current and the odo in order to create a picture of what's happening in the pipeline. On the photograph on the right, that's an example of a 38-inch tool that we built, foam tool that we built with a caliper attached at the end. And as you can see, the caliper is towards the center with reasonably long arms, because that particular line, the client was concerned that it had a major restriction of which they weren't sure what the depth of the restriction was. So with this kind of caliper, the pipe could squeeze into a restriction that's around 30% or even more, the pipe ID. Can I have the next slide, please, Blake? So our sensors are able to inspect steel, ductile iron, stainless steel, and we also have sensors for non-metallic pipelines, fiberglass and HDPE. Not eddy current sensors, but we have combinations of other sensors and caliper, etc. Excuse me. So we're doing a lot of work in water and force main pipelines of late. Most of them in the USA at the moment. We operate all over the world, but most of these lines are in the USA. And they come with their own set of challenges. We initially thought that it would be a walk in the park compared to being offshore on an oil and gas platform. But actually, sometimes they're quite challenging. And some of the lines might have T-bends in them, which our tools have to negotiate and come out on the other side undamaged. So quite challenging, but we've developed innovative ways to go through these lines and actually get data that has some meaning at the end of the run. Next slide, please, Blake. So here's a photograph of one tool that's been through a line. You can see all the pristine white foam is now dirtied with the line, but the blue polyurethane is relatively unscathed, so it's managed to come out pretty neat and keep the sensors intact. So, I mean, this is good for us because you see the computer at the top left of the screen is there downloading the data in this particular photo. Everything worked well. The pig wasn't too badly damaged. Sometimes the foam in some of the runs gets quite badly damaged, but as long as the sensors are intact, they still collect data and we get a good set of information to process. As I said earlier, our tools are easy to launch and recover, and they can pass through complex geometry. This is actually my last slide. There's one thing I haven't mentioned that I would have wanted to show you. It's in one of Blake's photographs, but in one of his photographs, he shows our tool with a cable attached to the end. That's what we call a communications cable, and we use that cable to switch the system on, download data from it, and to charge it. I think that picture will be maybe further down. Blake, if you go to the next slide. Next slide, please. Next, please. Next. This one. So you can see the technician there is holding the cable with an oval bit at the end and a yellow button. That's the on and off button. And it's got a few tentacles hanging out the back. One is for charging, one is for connecting to a laptop. So that's the way we connect it and download data. Very simple. Connect it to the end of the tool at the end of the run and download the data. I think that's all I really have to say now. Thank you very much for your attention.
Thanks, Bosco. All right, I'd like to open it up to the group now. If anybody has any questions, comments. Also, I'll be posting in this and also follow on emails the actual report from I2I on this, as well as a larger report from Mark on the whole project itself, which has some of the pictures from the verification digs and a bit more information on that if anybody's interested. All right, I think we've got our first question. Where does the access pit piping stop and the pig launching piping start? Who owns the pig launching piping? Mark, this one's for you. Mark, you're muted. Okay. Let's see. Get back to at least sharing this. All right, Mark, can you hear us? If you do, you are muted still. Maybe we've lost Mark. Let's see if I can answer that question. What I can do is if there's any questions that we can't answer, Glenn, we can certainly email you this. Are there any additional questions? We can see you, Mark, but we can't hear you. You want to just type in your answer to this question?
It appears he can't even hear you, Blake.
Yeah, it's technology. All right, well, we'll move on to our next question. Mark, if you can just, what I'll do is I'll chat with Mark offline, and then we'll just pose this next question. But Mark, if you can just text or type in the answers to your question, then we can at least get that going. What is the outside diameter of the pigs used on the 16-inch? So I can actually talk to this because our company, APS, did the pigging as well as the smart pigging on this project. The line was actually, it was 2 inches of debris on the inner pipe wall. So it was down to 12 inches from 16 inches. And we had to start, for this particular case, we started with 12-inch pigs, soft foam pigs, because naturally we didn't want to have any issues with a pig getting stuck under the river. And so we were very specific on where we started because there was multiple wells that went into the main trunk. And then you had the full length of the pipe starting at the very end. And so we, with our technicians, I believe we started from the lines closest to the river and worked our way out. That way we reduced the amount of debris that was going to be pushed with each pass.
Mm-hmm. Hey, Blake, can you hear me now? I think I found the button here. The first question, what was it again? Can you read it again? I can't even see the questions on this end.
Sure. It says, where does the access pit or piping stop and the pig launching piping start, and who owns the pig launching piping?
Yeah, that's easy. The last question is the city owns the pipeline, and the city owns the structures, and the city owns the pigs. So when they go back out and repig these pipes routinely, it's all their infrastructure. There is a as I recall, I had to look at the drawings again, but I believe the receiving structure is right there just upstream of the water treatment plant. What we built there was a valve, was a kind of like an H structure so that we could control, because there's two parallel 16-inch raw water mains coming into the plant. We could control each line and exit the pigs through this control structure into a lagoon that they commonly have been using anyway. So there's one structure just upstream of the water plant, which are used to control how sludge is pushed from the pigs. And then on the upper end, we had one launch structure, a permanent structure built at the very upper end of the first well that's coming into the system. And we also built another launching structure on the north side of the Kansas River, which was the managing the 6 wells on the north side, and build it there so that we could also isolate this system and just focus on the crossing under the Kansas River, because we didn't know where we were going to end up with the first time through. So we thought we'd have a structure there. And then there is one more structure on the south end where all 12 wells come together. And again, another control structure with valves in it so that we could push the pig in either pipeline. And so that, I guess that totals 4. If you want to actually get a PDF, I can get you a PDF of the plan sheets where all of that was built prior to the project getting constructed. If you just send Blake your contact information, I'll send those PDF drawings over to you, and you can see how we built everything prior to the pigging.
Okay, does anybody have any other questions?
I can see a question written in the chat. I think it's a 2-part question. One part will be for Mark and the other for me.
Okay. Back and forth there. Do the verification dig indicate any external wall loss, and can the eddy current sensors report on external wall loss?
Okay. Oh, okay.
Yeah, maybe you could answer that one.
Okay. Our sensors only work on the inside pipe wall. They cannot see what's happening on the outside pipe wall, or outside of the pipe wall. So if there was any external wall loss that was found, we didn't see it. We saw the undulations on the inside.
Dan, you would need an ultrasonic tool for that, which we also will be doing a webinar in the future on another smart tool that features ultrasonic capabilities. So for this with I2I eddy current sensors, it is strictly internal condition assessment, no external. And
this is Mark. We did use UT sensors where the pipe was visible. So when we built and constructed an access structure, obviously we were building it over top of the pipes, and we did UT testing wherever we could. I think we had about a dozen locations where we got measurement, and the answer is no. We saw no observable wall loss from the outside of the pipe. We chalked that up for good neutral soil conditions.
Okay, looks like we have another one from the Q&A. Let's see, is the pig launching piping with the hinged hatch an off-the-shelf part? No. Answer is no, it's not an off-shelf part. We all of our pig launchers are uniquely designed for each of the line, well, for various types of projects, but they are not off the shelf, I guess you could say. Any other questions? All right. Well, I just want to thank everyone again for taking the time to attend this webinar. We'll be posting it on our website, our LinkedIn, and we'll certainly email anyone who's interested, or we'll just email everyone, I guess, who attended today, a copy of the report, as well as a copy of the presentation that Mark has on this project at large. But thank you again. We appreciate your time and have a great day.